visual cortex is organized into 6 distinct layers. The molecular layer is the most superficial layer of the visual cortex. This layer is primarily composed of glial cells and horizontal fibers that integrate cross-modal information, as well as axons and dendrites from pyramidal neurons and other layers. The visual cortex is organized into 6 distinct layers, each with specific functions and characteristics crucial for efficient visual information processing. Granular and external pyramidal layers are layers 2 and 3. The external granular layer contains small pyramidal neurons, granule cells. The external pyramidal layer contains small pyramidal neurons, granule cells. The external pyramidal layer contains slightly larger pyramidal neurons. Both layers receive cortical input largely from the opposite hemisphere. They integrate interhemispheric signals, containing both excitatory pyramidal cells and small inhibitory cells. It receives input from local layer 4 pyramidal neurons, sends output primarily to layer 5 pyramidal neurons. The visual cortex is organized into 6 distinct layers, each with specific functions and characteristics. Internal granular layer is a crucial input layer for the visual cortex. It receives primary input from the thalamus, mainly sensory information, and is more prominent in sensory areas like the visual cortex. It contains excitatory pyramidal cells and stellate cells, strong connections to local layer 2 and layer 3 neurons. The internal pyramidal layer serves as the main output layer of the visual cortex. Composed of large pyramidal neurons called dead cells, mainly sensory information, receives inputs from cortex axons to various brain regions, including the thalamus, internal capsule, spinal cord, and other cortical areas. It is particularly prominent in the primary motor cortex due to its role in corticospinal output. The visual cortex is organized into 6 distinct layers, each with specific functions and characteristics. The multiform layer is the deepest layer of the visual cortex, composed of various neuronal types, including pyramidal, stellate, and other neurons. It has reciprocal connections with the thalamus, plays a role in modulating thalamic signals through gain control, helps in adapting sensory information to current situations. The visual cortex is organized into 6 distinct layers, each with specific functions and characteristics. Strong reciprocal connections between layers result in a dynamic inhibitory-excitatory balance that adapts to the brain's current state.